Hello, my name is Mark Hancock, and I'm a graduate student at Miami University in the Advanced Inquiry Program, and I would like to speak with you today about the use of camera traps in conservation. So, what is a camera trap? In this picture, we can see the basic anatomy of a camera trap. Camera traps are essentially battery-powered remote digital cameras that are triggered by a motion sensor. The more complex models have infrared lighting and enable nighttime photography. The apparatus is typically housed in a weatherproof housing with battery and memory capabilities lasting days to weeks depending on their use frequency. Now that we know what a camera trap is, you may be asking yourself, how might this device be employed in conservation research? A few examples of research that relies heavily on camera traps for data collection include 1. A 2017 publication in Nature Conservation research that identified and evaluated the role of mammals in the dispersal of invasive jackfruit in Brazil. Secondly, another 2017 publication in PLOS ONE used camera traps to A. improve the accuracy of sun bear population estimates, and B. correlate their presence with the density of tree coverage throughout their range. Thirdly, a 2018 issue of Global Ecology and Biogeography published research that used camera traps to study global patterns in mammalian carnivore residence and diversity. Now that we have covered a bit about the role of camera traps in conservation research, let's take a look at camera trap usage in the current studies through a project I am currently contributing to. Through the citizen science website Zooniverse, the Focus on Wildlife project photographs wildlife in the Cleveland Metro Parks and relies on citizen scientists, such as myself, to identify and categorize the species present for further analysis by the Cleveland Metro Parks. Now I'm going to give a quick demonstration here. I'm currently logged in with my information into my Zooniverse account, and I'm accessing the Cleveland Metro Parks Focus on Wildlife project, and this is an image here, a 3-part image from a camera trap that is identifying a motion sensor at night of an animal. To me it looks most like a coyote, and I'm going to go ahead and identify the coyote here, select that I only see one in the picture, I do not see any young present, and then I just have to identify it. Once I've done that, there could be other animals, but I don't see any in this set of pictures, so I'm not going to add any other identifications to this photo, and then I'm going to click that I'm done. And then I could continue on to the next image if I wanted to further identify more species. Now that we have some background in camera trap use in conservation research, let's examine some of the strengths and weaknesses of camera traps. First, let's look at some of the limitations. In 2013, Ike Kamphoff wrote in Foundations of Science that the majority of citizen participants in camera trap conservation come from South Africa, Europe, and North America. This limits the influence of citizen science elsewhere around the globe. Secondly, a 2015 examination of camera trap conservation research published in Ambio found that many projects utilized cheaper recreational camera traps, which resulted in significant deficiencies in deployment, operation, and data management compared to projects that used more expensive professional camera traps, which would maybe suggest that price is also a negative factor. On the other hand, in 2007, Alexander Nehamas published that the touching images of rare and candid wildlife can foster a connection and devotion to conservation and do more to help it. Similarly, the journal PLOS ONE published an article by Scottson et al. That identified several strengths of camera trap research, including its ability to be objective, data-driven, and facilitate easily repeatable methods. Lastly, I want to take a moment to cite my sources and encourage those of you that have watched my presentation to submit any questions, constructive comments, or relative contributions to the comments section of this video. Thank you.